Our next example involves solving a rational inequality using its graph. And instead of walking you through the process of solving walking you through the process of graphing the rational function, I want to refer you back to section 4.5 so that you can review that process of actually figuring out what the graph is going to look like. And so anyway, though, I wanted to make sure we covered the important material here for this particular problem, solving the rational inequality using the graph. So we have a graph, and then we have to do a little bit more, solve the inequality. Okay, notice that we have this function this inequality right here, where we have a function's values. We want to know when those values are greater than or equal to 0. Okay, so looking at this from a graphical perspective, we can see that if we let f of x equal that function that's on the left side, and we always have to make sure that when we solve a rational inequality using its graph that we set the right side equal to 0, and then we express, and that actually says that right down here in this part, where we have to make sure that the f of x is either greater than or less than, and also greater than or equal to, less than or equal to 0. 0 has to be on one side for us to be able to do this. Okay? So we already have 0 on one side, so we're good. We go ahead and graph the corresponding function. And we look and see where the function is greater than or equal to 0, keeping in mind that that means that the function itself is above the x-axis, or on the x-axis. I could also put that on or above the x-axis because we want to know greater than or equal to 0. Okay, and we can see that that occurs over the intervals from negative infinity to negative 3, not including negative 3 because we have a vertical asymptote there. But on the interval also from negative 2 to 2, including the endpoints, because greater than or equal to, so we get to include the x-intercepts. And then to the right of 3, we can see from 3 to infinity, the values of the function are going to remain positive. They will all remain on those intervals to the right of 3 and to the left of negative 3 above that horizontal asymptote. That's what that horizontal asymptote is for. It's going to provide a landing strip kind of for the graph. Nevertheless, we can see our answer right down here to the original inequality, and that's what we're trying to figure out. When is this function on or above the x-axis? Okay? Now, here's the one I want you to do. I want you to solve this inequality by graphing. Okay? Set up the first part for you, but pause the video now and solve it. Okay? So we have f of x equaling the left side and also factoring the left side. I can see that I can cancel one of those factors, but all that means is that there's a hole in the graph at some point. But nevertheless, it's going to look like this: x minus 5 over x minus 2. Did I get that right? Yeah. All right. So we have a horizontal asymptote, we know, of 1, y equals 1. We have a vertical asymptote of x equals 2. We have a hole in the graph when x equals negative 2, but when y equals negative 2 minus 5 is negative 7, negative 2 minus 2 is negative 4, so we have 7 over 4. So there's a hole in the graph there. Good reminder of how to find the hole. Okay, the domain is all real numbers except for 2 and negative 2. X such that x cannot equal plus or minus 2. And then the range, we can get that later. But let's go ahead and graph. Where's my black? Y-axis first, then the x-axis. Okay, so again we have x-intercepts. Where are the x-intercepts? At 5. So we have an x-intercept at 5. We have a vertical asymptote at x equals 2. Okay, and let's put that there. Let's section off this as well. Let's make it look better. Again, what was happening at 5? 5 was where we had an x-intercept. I'll put that in a different color. So an x-intercept at 5. We also had a vertical asymptote at 2, x equals 2. And we have a hole at negative 2, comma 7/4. Negative 2, comma 7/4 is somewhere right up here. So there's a hole there. And then remember the horizontal asymptote is y equals 1, so we need to put that in there. Y equals 1. 7/4 is above 1. Okay. Got that. Y equals 1. We have x equals 2, vertical asymptote. And so we're going to get the graph now. We can draw that. Just like this. Oh, what's the y-intercept? 5/2, so 2.5. So somewhere 1, 2.5 right there. Okay, so there's one part, and then here's the other part. Okay. Our initial inequality was this guy right here. And we can see that that occurs, that this function's values are actually less than or equal to 0 only right here. Okay, that's it. That's the only spot on the graph where the function's values are less than or equal to 0. And so how do we write that? So we say therefore, let's do this. Therefore, the function x squared minus 3x minus 10 all over x squared minus 4 is less than or equal to 0 on the interval from 2 all the way to 5. That's it. Okay. I think the next video I'm going to show you guys how to do solving these rational inequalities by algebraic methods. And by the way, I didn't ever show you what the range of this function was. We can see the range is all y's. Let's put the domain like that. All y's such that y cannot equal 1, and it also cannot equal the y value of that whole right there, which is 7 over 4. Okay? Alright. Feeling pretty good about this. I think you guys are doing a good job. You just have to make sure you understand how to find the whole, how to find the vertical asymptotes, horizontal asymptotes, and those are the hardest things. Normally students can figure out the rest pretty easily once they do a couple of these, but anyway, there you go. I'm going to give you guys one more video which would include how to find these, solve these inequalities by hand without graphing.